Hi, everyone. Thank you very much for coming to my presentations. And now I'd like to start my presentations, the latest status of the C Workgroup Shared Embedded Linux Distribution Projects. So my name is Yoshitake Kobayashi, C Workgroup Chair. And today, at first I introduce the C Workgroup, what we are doing in the C Workgroup at first. Then I moved to this Shared Embedded Linux Distribution Project. The role of C Workgroup is shown in this slide. We are trying to bridge between open source software community and developers and embedded system industry, which wish to collaborate with those communities. So, and this kind of work will be launched some project in C Workgroup. For more information, you can find the C Workgroup homepage on the Linux Foundations. And what we are doing is, currently we are active in some projects. First one is eLinux Wiki. Maybe we can find many embedded Linux development information on this website. And the second one is Linux in civil infrastructure systems. And this project has already launched as a separated project in Linux Foundations, which was announced yesterday. And the third one is device mainlining. Device mainlining is a big issue for our embedded peoples. So we consider how to involve this kind of effort to community, and we would like to solve this kind of problem for the Linux in use of industry systems. And the fourth one is LTSI for the long-term support initiatives. This project aims to have a long-term supported Linux kernel for industry use, which includes some extra functionality for which added on the LTSI kernel. And the last one is a shared embedded distribution project. And this project is, I will describe a lot more in the later slide. The motivation, and this slide shows the motivation of the embedded Linux, shared embedded Linux distribution project. And now Linux is running many kinds of systems, which includes not only PCs, but also a very small piece of kind of machines. That kind of machines includes, for example, we are using a very critical systems. And that kind of systems need to have very long-term support. So the reason why we started this project is we would like to share the long-term support effort with some distributors. And we also need to support our efficient number of packages for this kind of embedded products. And of course, we have a very standardized source code as possible as we can. So we decide to use, we decide to use Debian source codes based with Yokt project Porky. That means we are using a Porky's framework to build Debian source code for embedded systems. The reason why we choose Debian source code is Debian have already supported many variety of CPU architecture, which includes not only x86, but also ARM and PowerPCs. And that kind of CPUs, we are currently using many kind of products for civil infrastructure systems, such as a power plant, power generation control, or something like that. So, and also Debian is now starting to support more longer term. Debian usually only supports 3 years, and once next version is available, they will close their maintenance windows. But now Debian LTS trying to extend its support term for the 5 years. So that means if we use Debian's source code with Poki's build systems, we are able to have more longer term support. So what we are doing is currently creating a meta layer which using Debian source code. This is called a meta Debian layer in these systems. And this slide shows what meta Debian doing, and this meta Debian is just one layer for Poki build systems. And Poki build system have ability to build customized embedded Linux environment. And also it includes a bitbake for this purpose. And we implemented this meta layer on top of the Poki build systems by using Debian source code. So this is already available on the GitHub, and you can go to this website, and you can also clone the source code of it. And this is Poki build system structures. So to build an embedded Linux environment for the specific board, Poki build system supported many layers and also many metadata to create each open source packages which able to install into some specific board. And what we are doing is we built a new meta layer, and this is a meta Debian layer on top of the Poki build systems meta layers, and to use Debian source code. And currently, we focus to build meta Debian layer by using Debian 8.0, and this is the latest Debian stable versions, and just released 1 year ago. And also we are using Poki Zestro. I think this is a Poki version 2.0, and we also support upstream version Poki for this purpose. And when actually using this meta layer for the production development, we also need to customize this layer. So the customization is included, for example, compiler optimizations, and also add delete features for each packages. And also we can add or delete or package itself. This kind of customization could be done in your customized layer or customization template or something like that. So you can customize whatever you like. This is a big advantage by using a Poki and by using a source code on this purpose. And I just summarize the purpose of meta Debian layer is meta Debian aims to create embedded Linux environment with stabilized source code. This is a part of Debian's stable release and also Debian LTS release. We are using this kind of effort to build embedded Linux environments, and also to create fully customized Linux environment. We are using Poki build systems. And this is now it's open source, of course. And the reason why we would like to make it open source is we would like to share this kind of effort with anyone they're interested in. Because if we created just our company internally, but this kind of effort is not valuable for company itself. I think this is much better to share, even it is not stable or stable. That I think so. And we also start to contribute to the related projects. And first one is Debian. We are starting to contribute to Debian LTS project as one for is a not founder, supporter as a platinum member, and also we would like to contribute some security fixes for Debian LTS project, because once we fix some security fix for Debian project, this is also not valuable, not just valuable for ourselves, but also it's a big value for the community. So, and if we can share this kind of security fixes, we are able to have more stabilized Linux-based systems. That's why. So, the following slide explains how to use MetaDebian layer. This is a quick start. So, when you download the Poki environment, you need to copy Poki itself. Then you also need to MetaDebian layer into the Poki environment. So this is to download the MetaDebian layer is a specific part for MetaDebian layers. And you can also make changes to MetaDebian layer as many as you can, but it's quite easy to use. You just follow this kind of steps, and it's written in the README file inside the MetaDebian layer. And this is based on Poki, and when you create a core image, you just run a bitbake with core image minimal. So when you download Poki and MetaDebian layer, and then following this only 3 steps or something, you can create minimal packages for QMX64 or something. And this layer also supports the other CPU architectures, which include ARM and PowerPC and x86 64-bit environment. The following slide describes how we decide to create the recipes on the Poki environment. So when we created some recipes which using Poki itself, there are two solutions. First one is just modify Open Embedded Core, and the other one for the add recipes into a new layer. And the first solution is quite bad solutions. And once we made modifications on Open Embedded Core itself, we had serious issues. It's not maintainable. This is the biggest issues, because Open Embedded development is quite fast and moving forward a lot. So when we want to follow up this kind of effort, we cannot do anymore. So this is why we created the MetaDebian, just completely separated from the Open Embedded Core layer. So once we created this kind of layer, we now follow the Poki development. And that means, I think in October, I said at the Embedded Linux Conference Europe, we are using a DAISY. DAISY is Poki 1.6. But now we are easy to move to the upstream. And now we follow the upstream master branch and also the latest stable branch, Jethro. But when we created some recipes inside the MetaDebian layer, we also need to consider how we created such kind of recipes. And there are two solutions also. And first one is there are many recipes already available in the Open core. We just use this effort and just rewrite something on that recipes. And second one is use a part. Hello. Okay. Use a part of Open core recipes. We actually choose second one, but why I would like to explain why it is first one is not useful solutions. And when we use first solutions, just copy the Open-embedded original recipes and modify it to compile correctly. It is difficult to override some variables and functions which have already defined in the Open-embedded core. And also, sometimes it automatically follows the needed Open-embedded core updates that cause build failure. Something. For example, when we use bin utils or OpenSSL, and if we have a security fix on it, if we just copy the Open-embedded core environment, it sometimes includes this kind of fixes. But after that, Open-embedded core also adds the same fixes on it. That causes a serious conflict. So this is a not good solutions. Why? And our solutions is just select exactly what we need. So this is we can call the partial copies, and we can reuse essential data from Open-embedded core. And so when we implemented some recipes for Open-embedded environment, we need to define license information and also required files or something like that. It follows the same as Open-embedded environments. So, and when we created not good solutions like this, just use the source code. But other patches or license information or something like that, just using Open-embedded based. So this is, we can't say who is that. This looks like just using Debian source code, but many part of from the Porky. So which includes local patches from Porky and also many fixes from Porky. So this is this causes a big conflict on it. So then we make a policy how to create the Porky's recipes. And once we decided, this figure shows a bit more easy to understand. We use source code and init script and also a configure command and compile command or something like that. It follows the Debian original rule. So that's kind of rules are defined. If you well known about the Debian environment, you can find it under the Debian directory. There are one file which called rules that includes this kind of information. We are using this kind of information to create and to define compiler options or something like that. And then we use some partial patches from Open-embedded core. The reason why I use this kind of patches, Debian originally supports self-build environment. So Debian not support cross-compile originally, but we would like to compile source code packages by using a cross-compiler. To use a cross-compiler, we need to fix something. But this kind of fix usually available in the Open-embedded core. So that's why we're using this kind of patches. But the other patches, we don't touch it. So just use patches for cross-compiling. And after that, we just find this kind of directory structures, and we define this directory structure to create recipes and also some configuration files. And this package debian.bb and files is very core recipes. Package debian actually the name of the package, for example, BusyBox or something like that. And then this data are supporting cross-compiling and partially copied from the original recipes, as I mentioned before. And this Debian package DB class provides provide a fetch source code packages automatically and apply Debian patches automatically. And because Debian have a rule, exactly concrete rule, to how to apply the patches. So just we follow this kind of rules by using this Debian package.bb class. And after that, we also define the common parameters which is used by MetaDebian. So, and the following slide shows how to build this kind of packages. At first, usually Porky fetch the source code from a specific URI, then unpack it. After that, we created Debian patches. So first one is fetch. This is exactly the same as Porky doing, but Porky is able to support not only Git repository, but also binary source code packages, for example, some Turbo or something like that. But MetaDebian only support Git repositories. I will explain why we choose this policies. And then Git checkout by using a do unpack inside the Porky. And then do Debian patches. So do Debian patches only follow the Debian rules, which includes under the Debian patches directories. You can find many patches under the Debian patches directories because this is a strict rule for the Debian developers. So we easily find Debian local patches under this directory. So after that, we also apply patches for cross-compiling. So this is comes from usually Open Embedded Core. Then, we follow the Debian rules to configure the script and also to compile. But this configure option and also compile option can be overridden. Sometimes we would like to delete some features from the specific source code. For example, if we focus to install Apache web server, we don't need many features which included the original Apache servers. So we can just redefine this kind of configuration options by using this, by overwriting this kind of do compile and do compile options. And after that, when compile was finished, MetaDebian created dev packages. So this is what MetaDebian layer doing. So you can create root file system image, completely customized root file system image based on the Debian source code packages. And there are new features since October 2015. I presented some part of them to the Embedded Linux Conference Europe. But here is the new features listed in this slide. At first, we, as I mentioned as I mentioned on the slide, we now follow the Porky upstream development. So we can use a latest stable Pokey. Now it's a Jethro and also a master branch. But a master branch usually causes some error. The reason why we are using Jethro instead of master is this is just for that reason. But we also, when we find some conflict on master, we also fix it on master branch. So it's easy to fix. Now we can follow the Pokey's development. So, and the next one is we now supported new init systems. We basically supported on BusyBox init only because we are using this kind of systems for the very specific embedded environment. And that kind of environment not to include so much packages. So that requires only, we need to have simple init system. But someone says, we also would like to have a system D on it because Debian is now supports system D by default. So after I heard some requirement from someone, we started to support a system D now, and it's almost finished. So if you would like to test system D support, you can just define init subsystem is a system D or something like that. This is exactly the same as Pokey doing. And the other stuff is built on root file system with LTP installed. The reason why we need LTP on it is we would like to test kernel on the device. So that's why. So it's easy to install LTP to test the kernel itself on exact systems. So, and the other some useful feature is I can explain in the following slide. The first one is a Git repository mirror server. This is just an experiment. And the second one is tag-based source code fetch and build. And the third one is generates summary informations for images. These three features, I think, are not included in the Pokey. But we need to have this kind of features for production development. First one is a Git repository mirror server. We can now easy to create mirror servers because currently all repositories are uploaded into the GitHub. So when you start build something, the MetaDebian layer and Pokey try to fetch from GitHub. So if you want to create some root file system which includes 400 packages, so the build system try to fetch all packages from GitHub. So that's, if the network connection is not fast enough, it takes quite a long time. So now you can create a local mirror because a local network is much faster than outside internet networking connections. So you can create a Docker image for Git repository servers. And this one is called the MetaDebian Docker. This is a collection of the Docker file and script set to create a mirror server on your local machine. And if you or your company want to create this kind of image, this kind of mirror server, now it's quite easy to create. And once it creates, next time, this repository, this MetaDebian Docker have some script inside, and it's also try to fetch only modifications. So the second time, the synchronization between GitHub and local server is quite fast. And we also able to use this kind of mirror server as a master server inside, for example, your build environment. Because once you created some embedded Linux environment, you also want to know which source code was used for the development, for build. Because when, for example, the source code will be modified and updated for security fixes in Debian project, and we are also trying to follow this kind of effort. So that means original GitHub master repository will be updated frequently. But once you download it and synchronize the repositories, sometimes you find if you fail the build. So in that case, you need to find out which commit has caused this kind of issues. So if we are able to have some marking on that repositories by creating some products, you can easy to reproduce the original build environment and also the latest build environment, and it can be found easily. So this is the next feature. So we call tag-based source code be fetch and build. And what's purpose for this one is we would like to recreate a specific image which using exactly same source code and exactly same commit tag. So the second use case is we are using a specific source code version for one or more packages. So first one is like this. This is the latest commit, but this, if we find some error on this environment, we just trying to move this commit, and easy to reproduce this kind of root file systems. And if we create this, for example, this is a fix 3. By using a fix 3, there are no error on it. But for latest versions, you have some errors on it. So that means we can consider some of the changes caused between fix 3 and latest. So maybe we can find easily to find that more. The other use case is if we want to use some old version instead of the latest versions for some reasons. I'm not sure, but we also facing these issues. So we usually try to use the latest commit because the latest commit includes all security fixes developed by the Debian project. But sometimes we stay some old versions for some reasons. In that case, we would like to pinning for this specific repository, this one. And there are two features for this one. First one is git rebuild tag. So this rebuild tag assume a specific tag has been specified on all related source code repository. If the tag are unable to find some repository, that should be caused error. So if someone just edit maybe original one, then define that git rebuild tag, I'm sure it's failed because this is not exactly the same one. And the other one is git prefer tag. This feature assumes the specific tag has been specified on all or part of the related packages. So if even this option have defined inside the MetaDebian environment, that build step and just try to fetch from Git repository if the tag is available on it. But if there are no tags, just using the latest commit. So these two features is new. And the next feature is generate a summary information for images. This is very important information for product development. Once we created some root file systems, we also consider about legal issues. So first one is we need to reproduce the environment. And the second one is we need to know which package was used for this kind of this specific root file systems. And of course, we also need to know what kind of open source license has been applied for the packages. This kind of information could be useful. And now MetaDebian are able to create this kind of information automatically. When you create some root file systems which inherit summary options, the MetaDebian automatically could generate this kind of information. And maybe you can use this kind of information for that. It's also, of course, that information includes which Debian source code has been used to build this environment. So this slide shows things to do. What we need to do is we currently support very limited development board, which includes Raspberry Pi and Mino board, I think. But we now we start to development other BSPs, and we also want to create MetaZenbu. Zenbu means all in Japanese word. So something like meta all, and that is build all packages to make sure the build is fail or success. So this is a kind of some CI environment. And also someone now wants to have a package manager inside the MetaDebian, because once we created a build file and root file systems, it's difficult to update. Even we want to add just one package, we need to rebuild it, or most of them. So this takes, for example, sometimes more than 1 hour, or something like that. It is a problem for customers. So they would like to install pre-built packages. And the other one is, the last one is we would like to add semi-automated recipe generator, because now I said we are just following Debian rules files. So that rules files have already defined some options and also how to apply patches for the source code and something like that. Maybe we can generate recipes from this rules file. But I'm sure it's quite difficult because there are the rules file is very flexible. So that's why I said semi-automated. And last one is test. Test is, we are currently working with JTA and Fuego. And Fuego is just presented today, and to test the root file systems. So, but Fuego is only currently focusing by using a pre-built SDK to test a root file, to test a Linux kernel itself or Linux kernel environment. But what we want to do is, at first, we would like to build from scratch, then created a SDK, and this SDK automatically add to the Fuego environment, then test it. We would like to create this kind of sequence to test with Fuego. And I said we would like to have a pre-built package environment because the issues currently we have is we need to build from scratch and it takes a long time. So, and the other issue is the partial update is currently difficult. But if we can use a pre-built package from Debian or customized pre-built packages, something like this one, it's easy to recreate the root file systems later. There are some solutions, and I think a possible solution is just create a cache storage for the pre-built packages created by MetaDebian. The second solution is Debian has plenty of package set, and it's also assured by their quality assurance phase. So this kind of package, pre-built package, has a good quality than normal. I don't think so. No, I don't compare the other one. But I think this have already qualified by Debian project. So just using this pre-built binary from Debian, and now we are able to find ISA is created by someone, works with some Siemens or something, and that ISA layer enables to use Debian pre-built binaries to create root file systems. But currently ISA, I think, focusing to use pre-built binaries. But MetaDebian focus to use source code packages to customize a lot. So maybe the best solution is if we want to use pre-built binaries, maybe we can just use Debian source code and the Debian pre-built package if we able to use, for example, compiler optimization options or some other options as same as Debian doing. But if we want to change some options or some package options, some package feature options, we need to use MetaDebian. So now we have many solutions, but we need to find out, or maybe we can collaborate to build Debian-based, Debian source code-based or Debian-based root file system environment. So, and this is the current status of the MetaDebian layers. So now we supported x86 32-bit and 64-bit, and also many variety of the ARM environments. Okay, and PowerPC. And we are using LTSI-based kernel with preempt RT patch because most of our use cases for controllers, so which require to have real-time performance. And the user is currently still BusyBox-based minimal system is default. But we are also able to use systemd and also able to use a bash-based environment. And now we have about 400 packages, which include Windows systems. So now you can run x.org, and you can create some environment with a graphical one. But yeah. And yeah, I'd like to conclude my presentations. And what the shared embedded Linux distribution is currently we focusing to use Debian effort to create our free customized Linux environment by using a Porky. And MetaDebian intended to provide a wide embedded CPU support and stability and long-term support, which we want to have for more. If we want to have more longer time support, we will contribute to this kind of project. So, and You can find some other informations by here. Please feel free to contact us if you have any questions. So this is my presentations. So any questions? Yeah, please. And the question is what kind of BSP is supported? And only 2 or not more? So currently we are planning to support, but currently we are support only 2 development board, Raspberry Pi and also Minnow board. The other environment is only a virtualized environment by using QEMU. So, but now we have another project inside the CE work group. And currently we are working to support Dragon board and also Intel Edison board, something like that. Yeah, that's 2 more. 2 more will be, you can find.
So if I already using the regular and open embedding, with my boards, based on V-scale, I have a 6 processor. So will that work by default with the metadata, or I have to do something else?
Could you please once more? Yeah, or if you can use a mic, yeah.
So right now, we're using our own board based on the V-scale RMX6 processor. So the Intel processor is
I see.
4-core processor. So we already making work on open embedded in the actual environment. So if I'm going to using the method debit, will we work right away, or I have to you guys need to support it first?
I think, you can start to use MetaDebian layer, but you need to change, for example, compiler and also kernels. But it's easy to define in MetaDebian layer.
You will try it.
Okay. Other questions, please?
What about like commodity boards? Like I know you have Raspberry Pi. What about?
Sorry.
You have Raspberry Pi support, right? And then like, what about all the other like consumer level boards? Not the something with the IMX6. So that's sort of like a more professional level board. The other consumer boards that are being marketed, like the Kickstarter projects for the what do you call it? The chip. I don't know if you know about the chip. And the Pi 64 that's coming out.
I think that's the question is to support a more wider consumer level embedded processor like
$20 and below.
Yeah.
$20 below that's
Yeah.
for education.
I see. Yeah, and that's a good question. And to support this kind of board, we consider which kernel is supported for this board. So because of MetaDebian, by using a MetaDebian, you can easy to change the kernel source code. Yeah. So after that, you just change the compiler options for that target board. It's easy to add board support packages. Yeah, you can do that, I think. Yeah. So any other questions? I think it's almost time. Thank you very much for attending. Yeah.